Hello everyone, welcome to all of you. First of all guys, please confirm, am I audible and visible both? Audio video both are clear, I hope. Yes. So here we are going to discuss most expected concept of your upcoming GATE exam in engineering mathematics. So I am going to start with the linear algebra. As we know very well, dear students, linear algebra is one of the most, if I will say most important topic, then also it is right. If I will say highly weighted topic, then also it will right. Because if I talk about overall engineering mathematics, which covers 13 marks weightage, out of the 13 mark, this linear algebra can give you 2 to 3 mark. So surely this is a very important topic and you should not miss this one. Okay, so first of all, if you can hear the session, if you can, audio and video both are clear, then you should reply. Okay, and you should share the link of this video, this live session with your Telegram group also, within all the college students also, so that every student get benefit from this one. Okay guys, so just share it. All right, so we are going to start here. Okay, so as here in linear algebra, these topics, if I talk about the syllabus, these topics are in the syllabus: matrix algebra, rank of matrix, system of equation, eigenvalues, eigenvector, including Kelly-Hamilton theorem. But as our heading is, we are going to talk about here the most expected concept of engineering mathematics, and here in linear algebra I am going to start with the determinant. Okay, this is the very important topic, if I will say one of the very important. Why? Because now the base is determinant. As we know very well, in matrix algebra, means even in the complete linear algebra, determinant is important, rank of matrix is also very important, system of equation including rank, one question we can expect from that one also, eigenvalue, eigenvector is also important. But if you want to learn the remaining things, if you want to learn the rank, if you want to learn the eigenvalue, eigenvector, the most important tool which is required is a determinant. So that's why you should know each and everything related to this determinant. As I used to say, if linear algebra is a movie, dear student, then the very important character played by the determinant in this movie, I will say one of the lead hero is a determinant of this movie. Okay, so you should not miss this one. Even you can make with us notes also, because I will start from the scratch level of determinant. I will tell you all the important concept of determinant. We will talk about the tricks of determinant also, and then we will approach the questions including GATE problem based on the determinant, whatever is asked till now. Okay, so in this way we will approach this session. So let's start from here. So first of all, determinant of matrix. So what is determinant? If we talk about the basic thing, okay, the determinant, what is the condition for determinant, that we should know. If we are saying that we need to find out the determinant of any matrix, then the only condition, the matrix should be a square matrix. If a matrix is not a square matrix, if it is a rectangular matrix, then it's not possible for finding determinant of such type of matrices. So that's why the only important thing is matrix should be square matrix. So we can find out determinant only and only for the square matrix. This is the one of the very important condition for finding determinant. The same we can approach for the inverse also, because if we can find out the determinant of any matrix, then only we can find out the inverse of that matrix. Okay, now in GATE exam, if I talk about the GATE exam, here we are having maximum 3 type of pattern in the determinant. They can ask you the determinant of a 2x2 matrix, which is the minimum or the smallest question. They can ask you the determinant of 3x3 matrix, that is also possible. And maximum they can ask you, if I am talking about directly determinant, maximum they can ask you the determinant of 4x4. But if we are talking about the determinant of 4x4, so that 4x4 will not be a direct question. either that determinant will be changeable into the 3 cross 3 matrix or directly it will be 0. So later on we will talk about that one also, but right now, hello honey, welcome. So right now we are going to start with the determinant. So determinant of a square matrix, if I talk about the simple concept, what is determinant? So for a square matrix A, if I am having Aij n cross n is the order of this matrix, okay, or the determinant. Then for n is equals to 2 means for a 2 cross 2 matrix, if I needed to find out the determinant, then it is actually looks like the cross product, the very simple thing. So if I am having a matrix like this one, A11, A12, A21, A22, then it will be cross product of these two things. So it is nothing but A11, A22 minus A12, A21, right? And we can approach it directly. This is called the determinant. The symbol of determinant you can see in so many books like this one also, means within the sign of mod between the name of the matrix, or it is written as this delta also. So this is also denoting the determinant. If I am writing for the matrix A, then this is the determinant of A. So these two are the symbol of determinant. The basic thing, very simple thing related to the determinant, okay. Now let's, as I give you example of here, we just talk about the function or how to find out the determinant of a 2 cross 2 matrix. We can apply here with this example also. So if I am having this matrix, I need to find out the determinant of this matrix A, then it is nothing but the cross product. So I will go with the determinant of this matrix will be 7 minus 10, which is minus 3, my dear student, and we can approach it very easily. This is a very simple, the easiest thing related to the determinant. I will tell you each and everything related to determinant here. Alright. Now, so this is very simple and basic thing. Let's talk about the next thing, because here if you want to go for the determinant, actually you need to approach the tricks here. So if you want to apply the tricks, you need to go with the key points or you need to go with the properties. If you can understand very well the properties of determinant, then only those properties will work as a trick for you at so many places. So that's why we are going to deal here with the determinant's property. Achha, before that, if someone asks you to find the determinant of a 3 cross 3 matrix, then I don't think that you can, means it's tough for you. I will tell you, this is the basic method. Let me write down here one example. Okay, and after that we will talk about the specific method for finding determinant of 3 cross 3 matrix, also one shortcut method. So suppose I am having a matrix which is 1, 2, 5, okay, 1, 3, 0, or I am having 1, let it be 3, 1 and 2. If I need to find out the determinant of this one, then what I will do, dear students, I will directly approach it. So this when I will solve, I can go with this one. So here actually we are doing the cross product, but cross product with respect to the first row. If I need to find out the determinant of any 3 cross 3 matrix, so we need to go with this pattern. So in this one we will solve all the 2 cross 2 minor with respect to first row only, not all the rows. So if I will solve with respect to one, then I will not include this row and this row. I will talk about this one only. So here you can go with a very simple thing. So if you will go with this one, we can see the determinant is nothing but product of this one multiply with product of this one. Okay, I need to remove these two things. So when I will go with this one, I can see this is actually, sorry, when I will go with this one, I can see this is actually 1 multiply with 3 into 2, 6 minus 0, minus I am having the next element as 2. So when I will go with respect to 2, so what I will do, I will just remove, means I will not take the row and column of this 2. Other than this, I will take the element. So this will be 1 into 2, 2, okay, minus 0. And when we will go with the last element, which is 3, 5, which is 1 minus 3, 3 ja 9. So this will be 1 minus 9. So when we will solve, we can see this is 6, this is minus 4, and here we are having plus 5 minus 4. So this will be minus 20, and hence we can find out the determinant. So will you tell me what is the value if we will solve? We are having from here 2, we are having from here minus 20. So hence my determinant will be minus 18. So this is the common method, this is the simple method, this is the conventional method for solving a determinant of a 3 cross 3. Let me tell you about first of all the properties, important properties. Then I will tell you the shortest method, the trick for finding determinant of 3 cross 3 matrix also. Okay. So this is the basic method or the simple method which you can see. Clear guys? Okay, so very easily we can approach it. So if you are there in the chat box guys, so you should reply. If you can hear me, you should reply, because we want the session must be interactive. So if you will reply, then I can get to know whether you are approaching, whether you are getting my point or not. All right? Yes. Good evening Manoj, welcome. So clear? Okay, now let's come to the next one. So this is the basic method which I told you. Now let's talk about the properties, because here properties play a very vital role. Okay, properties can help you in so many questions. The properties automatically become as a trick here. So let's talk about the properties. So first of all, the basic property, first property is if we are having if 2 rows or columns, if 2 rows or columns of a matrix, okay, wait a minute. All right. Now, so if I am having if 2 rows or columns of the matrix are identical, then the determinant will be 0. This is a very important property, my dear student. If I am having a matrix whose 2 rows or columns are identical, and actually this will save your so much time. This is the most important property, most frequently asked property, which you can see in the rank also, which you can see in the system of equation also, which you can see in the eigenvalue, eigenvector also. So this is one of the very, very important property, I will say. What is this property? The property is if we are having a matrix whose 2 rows or columns are identical, then dear students, you need to put the determinant equals to 0. Determinant को आँख बंद करके 0 लगा दो. You can solve it very, very easily. Okay. Now, so let's talk about the next one. If 2 rows or columns of the matrix are interchange each other, we are having GATE question also based on each and every property of determinant. So you should not miss the properties, because directly after that I will come to the GATE question also. So if 2 rows or columns of the matrix are interchanged, then the sign of determinant will also change. Only and only sign will change. Numerical value remain unchanged. Okay, you should know about this one. If I am having a matrix, suppose I am taking one example. If I am having a matrix 1, 2, 3, okay, 5, 1, 7, 3, 2 and 9. Suppose I am having this matrix, and if I will interchange here the first row and third row, then dear students, whatever be the numerical value we are having for this matrix, it will be same after changing the row 1 and row 3, but only difference we will have that in this case, whatever the value we are having, the sign will be changed, numerical value will be unchanged. Only and only sign will be changed. It comes with the negative sign of the result of this one. So the sign will change, only and only sign will change, numerical value will remain unchanged beta. A direct GATE question has been asked on this property. You should not miss this one. Okay. Now, yeah, this is, it's not identical beta. It is not identical when we are changing the here. In the first case it is identical, but in the second property, it is actually when we are having 2 rows or columns, when we interchange 2 rows or column, then the sign will change. Okay, numerical value will be same, but the same thing if I will apply for the 3 rows or column, then beta the sign will also not change, because negative will become positive in that case. So it will be same as it is. Clear? Now the next property is determinant of lower triangular and upper triangular matrix. Let me write down here one example. Suppose I am having a matrix. Suppose I am having a matrix which is 1 5 7 0 0 sorry 1 5 7 0 2 9 0 0 and 3. Suppose this is my matrix. I can see that here this is a triangular matrix. Now which triangular? Either it is a lower triangular or upper triangular. Bachcho, will you tell me whether it is a lower triangular matrix or upper triangular matrix? Whether it is a lower triangular matrix or upper triangular matrix, just tell me. Lower or upper? What you need to do, if you don't know about this one, what you need to do, a basic thing, a simple thing, what it is. If we are having a matrix like this one, okay, I can see this is the diagonal. This is called the diagonal element, because if I will make a square or a rectangle or any figure, in that figure, the geometrical figure, we are having this side which is called the diagonal. So this is called the leading diagonal, and this is also a diagonal, but this is not a leading diagonal. So I am talking about the diagonal only here. So this is my leading diagonal. I can see this is my leading diagonal. Below this leading diagonal, if all the elements are 0, but so look at here. Below this leading diagonal, if all the elements are 0, then this matrix is called as a upper triangular matrix. If above this leading diagonal all the elements are 0, then this is called lower triangular matrix. So right now I am having upper triangular matrix. You can denote this one by U also. If someone tell me find the determinant of this one, then what I will do? I will not find out determinant with the basic method which I told you just few minutes ago. We will directly approach that for a lower triangular or upper triangular matrix. Determinant is nothing but product of its principal diagonal elements. So I can say this is 1 into 2 into 3. Hence my answer is 3 2 just 6. So this is my basic answer, simple answer. Right? Clear? Mr. Kovach, you asked about which is the meaning of identical. Beta, identical means same. Identical means same. If two things are same, if two rows are identical, same to same as it is value. If my first row is 1, 2, 3, my third row is also 1, 2, 3, then the determinant of that matrix will be 0, 100%. Is it clear? Okay, in that case the determinant will be 0. Alright, so here this is the upper triangular matrix. We can see below the principal diagonal, if all the elements are 0, that is called upper triangular matrix, and in this upper triangular matrix determinant will be product of its principal diagonal element 1 into 2 into 3, 6. So this is my property number 3, which is talking about if we are having a lower or upper triangular matrix, then its product of means its determinant will be product of its diagonal element. Clear? Okay, now let's talk about the next one. The next property we are having as if I am having a matrix A. If I am having a matrix A, and if I will find out the transpose of that matrix beta, then the determinant of matrix A is always is equals to determinant of its transpose. So suppose I am having an example. If I am writing here matrix A, which is 1 4 7 2 2 3 1 3 or 9. If I am writing my matrix like this one, this is my matrix A. If I will find out the transpose of this one, transpose is nothing but changing rows into column and column into rows. So if I will interchange here rows and column, so it will be, if I will find out, so how to find out the transpose? For finding transpose, we need to just take the first row. We will put the first row at the place of first column. We will take the second row. We will put it at the place of the second column. We will take the third row and we will put it at the place of the third column. Hence this is called the transpose of this matrix. So if I will find out the determinant of this matrix A, or if I will find out the determinant of this A transpose, it will be same beta. The result will be same in this case. Is it clear? The result will be same in this case. In the both cases, the result will be same. I hope this is clear. Everybody, I hope this is clear. Okay, so in a very simple manner we can approach it, in a easier manner we can solve it. This is called the property which is saying, because now directly we cannot use this one, but in so many GATE questions you can see we are using this property. The determinant of matrix A is equals to determinant of A transpose. So hence if I will find out one of them, then also it will be okay. So the property is important again. And the next one, directly GATE question we are having based on this one, that the product of determinant is equals to determinant of product. Determinant of product, right? What is this? Suppose I am having matrix A and B. If I am having matrix A and B, if I will find out the determinant of matrix A, okay, and then I will find out the determinant of matrix B. If, okay, I am having matrix A and B and one more matrix which is AB. One more matrix which is AB. So we are having three matrices A, B and AB. Okay. If I will find out the determinant of matrix A, then I will find out the determinant of matrix B, or if I will find out the determinant of matrix AB. Then here the product of these two determinants, you can see. What is my property? Product of determinant is equals to determinant of product. So I can see here product of these two determinant is equals to determinant of product. So this is the product of matrix A and B. So AB product of determinant, right? So this is very simple. Determinant of product is equals to product of determinant. So this you can approach directly. We are having GATE question also based on this one. If someone tell you ki if the determinant of matrix A is 3, determinant of matrix AB is 9, then find the determinant of B, then you can find out very easily. Or suppose this is 12, then you can find out very easily na. With this property we can use here, we can go with directly. This is 3, this I need to find out, this is 12, so my answer will be 4. I can approach it very easily, bacho, right? I can approach it very easily. So this is a very simple but a easy thing. Okay, so I hope it is clear to everyone. Okay, now so this is again a very simple property but important, because one GATE question has been asked based on this property. Let's talk about the next one, the determinant of a skew symmetric matrix of odd order. This directly you can use. Determinant of a skew symmetric matrix of odd order is always 0. One more thing you can add here, if the matrix is skew symmetric, if the order is odd, then the determinant is 0. But if the matrix is skew symmetric and the order is even, then the determinant will be a perfect square always. So you can add here if for the skew symmetric matrix which is saying A transpose is equals to minus A, okay, for this one, then the determinant, okay, the determinant of, and the order is also, and order is even, then the determinant will be a perfect square. So whether it will be 4, 9, 16, you can understand this one, perfect square. You can check with any example, right? So what is the property? Again a very important property. If we are having a matrix which is a skew symmetric matrix, let's take example. Do you know about the skew symmetric? Skew symmetric matrix is that one where if I will find out the determinant, means the transpose of any matrix is equals to minus A. If A transpose is equals to A, that is called the symmetric matrix. If for any square matrix A transpose is equals to minus A, that is called the skew symmetric matrix. So skew symmetric matrix, if that skew symmetric matrix is having odd order, so if I am having a matrix A which is skew symmetric, suppose 0, 0, 0, minus 1, minus 2, minus 3, okay, let it be minus 5, and here this is 0, 0 and 0, okay, and here we are having 1, 2 and 5. I can say this is a skew symmetric matrix. How we are identifying the skew symmetric matrix? In a skew symmetric matrix, principal diagonal elements are always 0, and mirror image is there with the opposite sign. So if you want to go with the basics of matrix algebra, what is matrix, which type of matrix, what is the meaning of this one, then you can refer on this channel only. We covered the basics of matrix algebra. You can go to the playlist of engineering mathematics by Priyanka ma'am, then you can check there. Okay, every detail of matrix algebra is mentioned there. Okay, and here I am talking about specifically determinate. So whatever is required I am giving you reference, but directly you can, if you want to learn in the detail, you can go to the playlist. Now here, as I can see, this is a skew symmetric matrix because the mirror image is also there with the opposite sign. So if I want to find out the determinant of this one, I can see the result is 0 into 0 into 0. So the determinant will be 0. The determinant will be 0. Why I am saying? Because this is the odd order matrix, odd order skew symmetric matrix. If you will find out the determinant, suppose with respect to this one, then also it is 0. With respect to -1, then also it will be 0. Okay, so when you will check overall, the determinant of a skew symmetric matrix of odd order is 0. But suppose I am having a skew symmetric matrix of even order. So if I am having a matrix whose odd order, okay, sorry, even order. So this is my matrix. This is my skew symmetric matrix of even order, because here the order is 2 cross 2. If I will find out here the determinant, it will be 0 minus minus plus 4. So this is 4. I can see this will be a perfect square. I can see this will be a perfect square, bachcho. So very simple thing. Why? The reason behind having the perfect square, this is the principal diagonal which will always 0, and here we are having the mirror image in the opposite sign with the mirror image. So every time we are having the same numerical value. So that's why it will be a perfect square every time. So if the matrix is skew symmetric, okay, order of that matrix is odd, then the determinant is 0. Order of that matrix is even, then the determinant will be a perfect square. You can use this one. Clear, guys? So basic, very basic and simple thing we can use here. So these are the few properties which we learned. Okay, if you these are the important properties actually which we learned. So you can use these properties at so many places in determinate, even throughout the chapter linear algebra. Clear, guys? Okay, now so here we can two simple things we are having. The first is if someone tell you ki we are having a singular matrix, so you should know what is the singular matrix. If a matrix is a singular, it means its determinant will be 0. Or I can say if in a matrix determinant equals to 0, then that matrix is called as a singular matrix. So here you can see singular matrix is having determinant is equals to 0 always. And if a matrix is a non-singular, then the determinant must not be 0. Okay, so the determinant will not equals to 0 at all. Okay, so you should be clear with this basic concept also. If the determinant is 0, it means the matrix is automatically a singular matrix. If the determinant is not equals to 0, it means the matrix is called as a non-singular matrix. Clear, guys? Okay, now I hope you are getting my point. I hope you can understand my point. Whatever I am dealing, I hope you guys are getting very easily. Clear? Okay. So now we can start with the questions. Okay, I am giving you one example of the singular matrix. Then I will tell you about the trick for finding determinant of a 3 cross 3 matrix in a new method. So this is a basic example for which value of x will the matrix A become singular, as it is already saying that this matrix A will become singular, but for which matrix of which value of x. We are having options also. If you want to go here with the option, then you can start by putting the values here. You can check here. Okay, but ultimately what is my motive? I should know about here what is my motive. My motive is I need the determinant of this matrix equals to 0, because you said na singular, so it is giving me clear indication that determinant must be 0 here. Now this is your task, that in how many ways you can put determinant equals to 0. The very first or simple way, if you want to put determinant equals to 0, you can go with this one, that you are having a matrix 8x0 4 0 2 12 6 0. You can directly put it equals to 0. You can solve and you can get the value whatever it is. right? This is the first method, which is absolutely right. The second method also we are having for this one, that if we are saying that the determinant of any matrix or any square matrix is 0, it means 100%. It means 100% beta there will be two rows or columns are identical, isn't it? We already learned in the very first property na कि if in a matrix any two rows or columns are identical, then 100% determinant will be 0. I am using this property in a reverse manner. If the determinant is 0, it means in that matrix any two rows or columns are identical, right? So I can use this one also. Yeah, Vishal, welcome. I can use this one also here. So I will solve this question with the two methods. So first method you can see here, I am approaching this first method. So you want even three methods also we can use here. The third one is the option also. So if I am having the matrix 8x0, the next is 402 and the next is 1260. Okay, this is my matrix as it is given to me. Determinant is equals to 0. Why? Because the matrix is singular. This is the condition. If I will approach it beta, then what happen? It will be 8 into 0 minus 12 minus x with respect to x. If I will find out the determinant, so it will be minus x. 4 into 0 is 0 minus 24 plus 0 is equals to 0, isn't it? If I will solve this one, I am having minus 96 minus plus 24x is equals to 0. If I will solve it beta g, it will become 24x is equals to 96. So will you tell me what is the value of x here? What is the value of x here? So ma'am, here we can see very easily 24 4 ja 96. So it will be x is equals to 4. So I can tick on the option A, that my result is option A is equals to 4 and I can approach it. Isn't it? Zara batao to sahi, isn't it? Can we approach like this one? Yes, this is actually very simple method, the conventional method. If a student will go with this one, nothing is wrong here. Nothing is wrong here, that for sure we know. Okay, so this is absolutely right method. We can go with the first method. Okay, as it is already saying that the determinant is 0. So when the determinant, we can put directly the determinant is equals to 0. When we will solve it, we can get the value of x is equals to 4. Clear? So this is the first method. So my answer, already I am having the answer. Suppose if I want to go with the second method, then in this case beta, what is my matrix I am putting here again? 8x0 402, okay, 12 6 and 0. All right, I'm having here 8x0 402 and 12 6 or 0. All right, now I can understand this very easily, that you are saying already ma'am ki determinant of this matrix is 0. So beta, you should know when the determinant is 0. When the determinant is 0, if in a matrix any two rows or columns are identical, that we already learned na, any two rows or columns are identical, the very first property of today's session, okay, of determinant. So identical, then the determinant will be 0. Isn't it? So if I can make here, if I can identify that here two rows are actually identical, then the determinant will be 0. Now look at the pattern. I'm approaching you, I'm just approaching this question in a reverse manner also. Look at the pattern, as I'm having the determinant is equals to 0. Look at the pattern. If from the third row, I can see this first row and the third row having similar pattern. First row and third row having similar pattern, because they are having the third element as 0. So here also 12 6 is 0 means something something and 0. Here also something something and 0. Okay, so the third element is same. I need to check these two elements of first row, these two elements of second row, and I can solve it within the 10 second. which can give me the hint that 12 and 6 I am having. If I will take common from here 6, it will be 6 2 ja 12, it will be 1. So if I am having third row as a 2 1 0, my first row must be 2 1 0, because the determinant of, if determinant of any matrix is 0, then in this case 100% any two rows or columns are identical. So how this is possible? Ma'am, this is only possible when you are putting here 4. Okay, if I am not having option, then also I can go here. If I am putting here 4, if I will take 4 common, then it is possible to have 2 1 0. Hence in this case first and third rows are identical, and hence my determinant is 0 0. Is it clear? So in this manner, in this specific manner, in this spatial manner, you can solve this question, but for that you need to think like that. You can solve this question within the 10 seconds. You can click this one if you know the reason behind this one. If you are having enough practice for this property, all of my students, I'm damn sure about that, those students are learning with me on our IMS GATE Academy. All of them solve this very easily, because they used to learn with us the property. You should know, you should use the different thing. You should try to solve the question in a different manner. Everyone can solve like this one. Everyone can solve like this one. If you want to be different, you need to solve the question differently. So this is the different method. This is the superb method which you can solve even without using pen. My dear students can solve this one. Okay, so this is the simple or specific method, but still, as I told you, this is also a good one, but this is the best. This is the best. This is the good, but this is best. Okay, you can choose about which one you want to go. So this is the answer directly I can put, option A. Okay, now let's approach to the next one. Before approaching to the let's approach to this one. So here I am going to tell you the trick also. Bachcho, you should reply if you can understand my point. If you are enjoying the session, you should reply ki yes ma'am, we are getting your point. Yes ma'am, everything is clear in our mind, so that I get to know ki yes, everything is very good here. Okay, now what I am saying ki for this one we will learn a specific pattern to solving any question. So this is a very important trick also. So let's talk about this one. We are having 1 1 1. Okay, 1 1 plus A, 1 1 1 and 1 plus B. Okay, if I want to find out the determinant of this matrix, how I will approach beta? How I will approach the basic thing? First of all, a very important and key point you should write down always whenever you are dealing with the questions of linear algebra. Either the question is of determinant or inverse or rank of matrix or eigenvalue. If you need to find out, if you need to solve that one, if you need to find out the determinant, if you need to simplify that one, you should always remember one important key note beta, ki if the very first element of any matrix is 1, if the very first element of any matrix is 1 and you want to solve further that matrix, so you should always make all the elements below that 1 0. This must be your attempt, this must be your effort. Okay, how? If the very first element of any matrix is 1, you should always try to make all the elements below this 1 equals to 0. If you can make it, then you can solve the question very easily. So here this is my approach. I am going to solve this one with the help of this simple pattern only. So I am going to use here the row transformation. In this question, I will approach at the place of second row, I will go with R2 minus R1. At the place of third row, I will go with R3 minus R1. So this, if you can apply this one now, it will automatically give you the hint, okay, what is next. So I can see here the very first element is 1. If I know this key point, keep in a matrix, if very first element is 1, my next target is to making all the elements below this 1 0. So I am approaching that target only. I want to make this 1 0, this 1 0. So that's why I am doing here R2 at the place of R2, R2 minus R1, R3, R3 minus R1. If I will approach it beta, then this matrix will become 1. The first row is same as it is. This will become 1 minus 1 0. This will become 1 plus A minus 1 A. This will become 1 minus 1 0. Right? Here it will become 1 minus 1 शून्य, 1 minus 1 शून्य, 1 plus b minus 1 b. Now बच्चों, can you tell me the determinant of this matrix? बोलो जरा. Can you tell me the determinant of this matrix now? Yes, 100%. Within the 15 second, 15 second, you can find out the determinant of such type of question. If we are having this matrix, then the determinant is very easy, ma'am. How? Arey beta ji, this is the upper triangular matrix. If this is upper triangular matrix, we know the property which work as a trick, that the determinant of our upper triangular or lower triangular matrix is nothing but a product of its principal diagonal elements. So this one multiply by this one, so it will be 1 into a into b. Hence my answer is ab. Done. Very easily, literally very easily you can solve this one, isn't it? So you can see, we actually understand if we want to understand. So if you want to approach this trick, if you want to go with the trick, then only you can approach it. Otherwise, for every question we are having conventional method, for every question we are having the basic method, which is very simple. Okay, clear? So in this way we can solve. Now from here we can have a key point also, we can have a conclusion also. So right now, so I am having a matrix which is 3 cross 3. If I want to go for more, so if I am approaching a matrix which is the 4 cross 4 matrix, then what about the result? What about the result? So you can conclude here कि ma'am, this is actually the pattern of this 3 cross 3 matrix. So now rather approaching this one, rather using again the row transformation, I know this is my basic pattern, so I will use it directly as a conclusion here. If I am having a 4 cross 4 matrix like this one, then my determinant will be my, now I will not use here the row transformation, I can directly solve. So if I will go with the determinant, tell me bacho, what is the answer? Remember, my answer will be 1 into A into B into C. So this is A, B, C. If the order of the matrix is 4 cross 4, then my result is A, B, C. If the order of the matrix is 3 cross 3, then I am writing my result as A into B into 1. So which is AB, which I told you the proof. About that I told you the proof already, na? So this is the proof which we had a discussion. If I want to go with the 4 cross 4 matrix, this is ABC. Suppose I want to go with the 5 cross 5 matrix, बच्चों बताओ जरा, what is the result in that case? Please write down in the comment box what is the result in that case. If I am having a matrix like this one, which is a 5 cross 5 matrix, so what is the result in that case? Everyone should reply. In that case, what is the result? You will say, "Arey ma'am, we are having the same pattern, we are approaching the same pattern. So in this case, I can see this is 1 into A into B into C into D. So my result is A, B, C, D. Remember, I am not writing 1 plus A into 1 plus B into 1 plus C into 1 plus D. I am writing only 1 into A into B into C into D. Is it clear? प्यारे बच्चों, this is the magic. You can use it directly, this property, so many times whenever we are having the question like this one. Very good. Whenever we are having the question like this one. So now on the basis of this one, will you tell me what is the result of this question, बच्चों? I am giving you the time of 30 seconds, which is maximum, because this question that you can solve in the 10 seconds, but still I am giving you the time of 30 seconds. I want to reply from you, what is the result of this question based on the concept which we learned right now only. 111, 151, 116. What is the determinant of this matrix, bachcho? Just tell me. What is the determinant of this matrix? Just tell me. Very good. I can see the reply from Soumyala. Okay. What about the others? Very good. Ronak is also there with the reply. Very good. More replies. I want to see more replies. Prashant is also there with the reply. Very good. Anyone else is there who want to do who want to write down the reply? Okay. Now look at here. Look at here. One more Swagita is with 30. Mr. Coach is also with 30. So very good to see that out of those students who replied, only one student is correct. Otherwise, everyone is wrong. Ronak is corrected himself after a few minutes. Okay, yeah, very good. Anwar is also right. Beta, look at here. Why you are not approaching my point correctly? I said na ki if my question is this one, then my answer is 1 into A into B. So my result is AB. I did not write down here 1 plus A into 1 plus B. When I write down 1 plus A into 1 plus B, no na. So when I am looking here, I can see my question is 1, means first element is 1. Okay. This is 5 to everyone. This is written 5 to everyone in this word, but for you, if you are attending this session, for you, this must be 1 plus 4. Are beta, this is 5 to everyone in this word. But if you are attending this session, if you want to score very well in the GATE exam, then for you this is not 5, this is 1 plus 4. Acha. Now the same thing I can see here, this is 6. So this is 6 to everyone in this word. But for you, this is 1 plus 5, so which is 1 into 4 into 5. Beta ji, your result will be 1 into 4 into 5, which is 20, not 30. If you are writing 30 means you are saying ma'am 1 into 5 into 6, which is absolutely wrong. So if you want to approach the question in a simpler manner, within the 10 seconds, literally you can solve the question within the 10 seconds, that is my guarantee. But you should know, you should understand what is written here. You can see what is hidden there. So that's why this is 5 to everyone, but for you this is 1 plus 4. This is 6 to everyone, but for you this is 1 plus 5, my dear student. And that's why the result is 20. This is right, this is wrong. Clear everyone now? Is it clear everyone now? So those students who writing the result as 30, I hope now you corrected yourself ki why this is not 30, why this is 20. Okay, so in this manner you need to approach, in this manner you need to go with this one. Alright, now more questions we will have, don't worry, we are having so many questions because the concept whatever is there we learned, now we are in the process of going with the questions only. Okay, clear? So this is the thing which you will remember. So this I am writing as a keynote, you should remember always. Okay. Now let's come to the next thing. So about this one I will tell you the trick how to find out the determinant in a simpler manner. Okay, if you can understand the new method of finding determinant, then that method you can use in finding the inverse also. So that's why I'm going to tell you this method. So let me write down the matrices. My matrix is 0 1 2, my matrix is 1 2 3, my matrix is 3 1 1. This is my matrix. Okay, right? I need to find out the determinant of this one. I need to find out the determinant of this one. So how I will find out determinant? With the new method. So now I am going to tell you pyare bachcho the determinant of a 3 cross 3 matrix with the trick. Determinant of 3 cross 3 matrix with the trick. So this is only and only for 3 cross 3 matrix. Neither you can use the method which I am going to tell you in 2 cross 2, nor you can use in 4 cross 4. This is only and only for 3 cross 3 matrix. Okay. Now, if we are having matrix, what we need to do? We will write down first of all the matrix as it is. So I am writing my matrix as it is 0 1 2 1 2 3. This is 3 1 1. Okay, G. Now what I will do, I will repeat my first 2 columns. First column is 0 1 3, second column is 1 2 1. Okay, right? What I am doing, I just write down here my matrix as it is, whatever is given to me. This is my matrix which you can see in the yellow color. The pink color you can see here, this I repeated first 2 columns which is 0 1 3 1 2 1. Clear? Okay. Now we need to solve here. We need to write down the results. So for finding this one, we will go with the grouping. For finding this one, we will go with the grouping. Okay, now we will go with the grouping. So first of all, we will go with the grouping from upper to the lower side. We will go with the grouping from upper to the lower side. So if I will multiply 0 into 2 into 1, 0 into 2 into 1, the result will be, if I will go with this one, the result will be 0 into 2 into 1, ma'am, 0. The same pattern I will approach here. So if I will go with the next one, means this one, I am making groups here. What I am doing, I am just making groups here, groups of 3 3. Okay ji, so groups of 3 3, ma'am, you started from this one, 0 into 2 into 1. In the way I am drawing the line, I will multiply the numbers in my mind. जैसे जैसे मैं यहाँ line draw करती जा रही हूँ, in the same manner I will multiply in my mind the numbers. So this is 0 into 2 into 1, the result is 0. Okay. The next one is 1 into 3 into 3, the result is 9. So I will write down here, the result is 9. So this will be 9, right? 3 3 is 9. Now same if I will follow this one, 2 1 into 1. So 2 into 1 into 1 is 2 only. Okay, what I did here, I am just making the groups from upper to lower direction. Upper to lower direction. The same process I will follow. From lower to upper, but with the opposite sign. So this I am writing here, minus with the opposite sign. Now I will approach. With the opposite sign, now I will approach, bachcho. So if I will go with the opposite sign, I can see this is 3. This is 3 into 2 into 2. 4 3 ja 12. The same manner, this is 1 into 3 into 0. Ma'am, this is 0. This is 1 into 1 into 1. This is 1. So I can see from here I am having 9 plus 2, 11. From here I am having 12 plus 1, 13. So 11 minus 13 is minus 2, beta G. This is your determinant. If you can understand this method, then actually you are doing the half inverse here. So this method will helpful in finding inverse of any matrix. So that's why you should know about this one. This is the easier method, no doubt. Okay, but this is a very good method also. Clear how to do? I am repeating myself. If anybody having any issue, you can understand again how to approach this one. So we can understand very easily. If I want to go with this one, so I can understand here. The point is, this is my matrix. I need to write down my matrix as it is. This is 0 1 2 1 2 3 3 1 1. Then what I am doing, I am just repeating my first 2 columns here. You can see here first 2 columns are here. Okay, these are the first 2 columns. Then what you are doing, you are just multiplying, means we are just making here the groups of 3 3 from upper to lower direction. So you can see I just multiply 0 2 1. So this is 0. Then I am approaching here 0 3 3. This is 1 3 3. This is 9. Then I am approaching here 2 1 1. This is 2. Clear? Now minus, when I will go with the same thing, minus I am writing. Why? Because now I will change my direction. Initially I am going from upper to lower. Now I am going from lower to upper. So that's why I am writing here the negative sign with the big bracket. So this will be 3 into 2 into 2. In the way I am drawing the line, I will multiply the numbers in my mind. So 3 into 2 into 2. This will be 12. Next is 1 into 3 into 0. That is 0. Next will be 1 into 1 into 1. That is 1. So now you can solve it very easily. 11 minus 13. The result is minus 2. Okay. No, this is not, as I told you, Ankit, this is only and only for 3 cross 3 matrix. This is not for 4 cross 4 matrix. The thing which I am telling you is not for the 4 cross 4 matrix. Okay. So this is only and only for 3 cross 3 matrix. I hope this trick is clear to everyone. Okay, if we need to find out the determinant of 4 cross 4, that I will tell you later in the rank, when we will talk about the rank, which is again very important concept. So when we talk about the rank, I will tell you how to find out the determinant of a 4 cross 4 matrix also. I hope this is clear to everyone now. Okay, so this is a very simple thing. Now will you tell me the result of this question? will you tell me the determinant of this question बच्चों without using pen? Can you tell me the determinant of this question? No ma'am, without using pen तो नहीं बताएंगे. Okay, then just use my method and just solve it. By my method, just solve it. I am giving you time. I am giving time to everyone. I want to see. I am giving you 1.5 minutes. Okay, which is more than enough. Okay, 1 minute and 50 seconds. Just take it. So this is more than enough for solving this question. What is the determinant? What is the determinant of this one? What is the determinant of this one? Yes, dear students, tell me what is the determinant of this one. We can easily approach the method which we learned right now here only. Okay, Manoj is replying with 1. Anyone else is there with the determinant? Ankit is replying with 0. Anwar is replying with 5. Okay. Is it? Ronak is replying with 5. Okay, so different answer I am having. Confusion ही confusion है. Solution कुछ पता नहीं. चलो आओ. We will talk about the solution here. I can see the different results. Okay, so I can see that till now majority is with 5. Till now the majority is with 5. Let's approach it. So we are having the matrix. What is the process? The process is, ma'am, you need to write down the matrix as it is. So 1 2 2 2 1 2. Okay, 2 2 1. This is my matrix. Now what I will do, I will just write down here the first 2 columns. So 1 2 2 1 2 2. Okay ji. Now what I will do, I will write down here the result as I will multiply with the, I will multiply here in the grouping of 3 3. We will start from upper to lower. So this is 1 into 1 into 1 1 plus this is 2 into 2 into 2. Ma'am, 2 into 2 into 2 is 8. The next is again 2 into 2 into 2, that is 8 प्यारे बच्चों. Minus if I will go with the opposite direction, this time I will go with the opposite direction. Okay, that's why I am putting here the negative sign. So you can see here it will be 2 into 1 into 2 4, 2 into 2 into 1 again 4, 1 into 2 into 2 again 4, right? So we can see the result is 8 plus 8, 16 plus 1, 17 minus 12 we are having. So my final answer is 5, my dear students. So very good, clapping for those students who approached means absolutely right. So I can see Ankit is with 7. No, Mr. Kavach absolutely right. Somarjo, you are right. Ronak is right. Anwar is also right. Shabash. So Manoj and Ankit, I hope you can change it. You got it. Why you write down the result as wrong? So maybe you did some simple or the calculation error. So you should not repeat these things again. Right? So I hope this thing is clear to everyone. Whoever is learning the 3x3 determinant with a new method, with a simple method, with the easier one, I hope this is clear to you. In this manner, we can solve the determinant of any 3x3 matrix only. Okay, now let's come to the GATE question. So I hope you can tell me the result of this one, because based on this one we read already the property. Look at the question. The determinant of a matrix A is 5 and the determinant of matrix B is 40. Then the determinant of matrix AB is what? Determinant of matrix A is 5. Okay, G, this is given to me. You can write down here everything. Arey beta, while I am writing this question, you can solve and you can tell me the result in the comment box, because this is as simple. We already learned this property in today's session, and that after property I will tell you the example also. If you learned very sincerely, 100% you can tell me the answer of this question. So this is A, the B is 40. So beta G, AB, arey ma'am, AB is nothing but a product of determinant is equals to determinant of products. So determinant of product is 5 into 40. So this is nothing but 200. It will not take maximum 10 seconds. Arey maximum 10 seconds, within maximum 10 seconds you can write down the result ki ma'am my answer is 200, done. The question is done. Isn't it? Arey recently, just a few minutes ago we learned this property, and we can see the GATE question is based on that property. I am repeating my point again beta, every property of a determinant is having GATE question. You can see the GATE question, and if you know the property, every property will work as a trick for you. Yes, very easily. Very good, Ahmed, Somerju, okay, and Kovach. Absolutely right. This is 200. Chalo, now look at here. This is a very simple but a good thing. For that I will tell you two properties also. Now look at here, A and B are matrices of 4 cross 4 such that A is equals to 5B. Determinant of A is equals to alpha into determinant of B, then the value of alpha. Before approaching to this question, you should know about these two key points related to the determinant. What? This is again very simple. Ki beta, suppose I am having a matrix A. If I am having a matrix A, it will be anything 1, 2, 3. I am taking random examples. 2, 1, 5. Okay, 0, 1, 3. Suppose I am taking any random example. So if you want to find out the determinant of this matrix, okay, I am having the matrix A. If I need to find out the determinant of this matrix, but before finding the determinant, suppose in the first row, what I am saying, in the first row of this matrix, if I multiply with any scalar number k. So if I multiply the k with the first row of this matrix, so this will be k, 2k and 3k. If I will find out the determinant of this one, then my result means whatever the determinant earlier you are finding, that determinant will multiply with that scalar k only. The determinant will multiply with that scalar k only. So you can write down the property, if in any matrix, any row or column has been multiplied by any scalar k, any one row or column. So this must be important. Any one row or column has been multiplied by any scalar k, then the determinant will also multiply by that scalar k. Determinant will also multiply by scalar k, okay, by that k. So that the thing I just told you here. So if this is my matrix A, whatever the determinant I will find out here, this will be the determinant of A. So the determinant of A, if I will multiply the first row with the scalar k, then the new determinant will be the old determinant multiply with that scalar k. So your determinant will multiply with that scalar, hence it will be the determinant of new matrix. Clear? Suppose we are having two parts for this one. So suppose every row of this matrix you multiply with that scalar. Suppose I just multiply first row with the k, second row also with the k, third row also with the k. So every row or every column of this matrix if you multiply by any scalar k, then your determinant will multiply by k power n, where n is the order of matrix. This is very important. So I am writing here, if every element, or you can say all rows or column, all rows or columns, okay, multiplied by scalar k, then multiplied by scalar k, then the determinant, will be multiplied by k power n, not k this time, by k power n, okay, not k. So where n is the order of matrix, where n is the order of matrix. Is it clear, प्यारे बच्चों? So this is your second property. So here if I will go with this question, where is my question? This is, I can see here what is given to me. A and B are 4 cross 4 matrices. So this is given to me, A is equals to 5B. This is already given to me. Okay ji. And one more thing is given to me, कि determinant of A is equals to alpha into determinant. I need to find out the value of this alpha beta, right? I need to find out the value of this alpha. How to find out the value of this alpha? How we will approach the value of this alpha? So one very simple thing we can understand, कि if I will go with the determinant of this one, if I want to find out the determinant of this one, I can see one very simple thing, that this matrix B is multiplying here with the 5. Matrix B is multiplying here with the 5, then beta, if I will take the determinant both the side, then I will take the determinant of 5 into B, na? Then I will take the determinant of 5 into B. If any number is inside this determinant, if any scalar is inside this determinant, then if you want to take this scalar outside, then you will not write down this as 5 into determinant of B. No. You will write down here 5 into power of n, because why? When it is mentioned na, your B, matrix B is multiplying with 5. It means your every row of this matrix is multiplying with this 5. Every element of that matrix is multiplying with 5. So if you want to take 5 common throughout the determinant, then it will be k power n. It will be as a k power n, right here. So that's why here when you will write down, this will come as a 5 power n. Now what is n? Now n is the order of the matrix, as order is mentioned to us already. So this will be 5 power 4 into determinant of B. So now you can compare very easily कि this is same as the determinant of A is equals to 5 power 4 into beta. If I will compare this one and this one, I can see very easily that alpha is equals to nothing but 5 power 4, which is 25 square, which is 625. So by comparing these two things, we can write down alpha is equals to 5 power 4, alpha is equals to 625. बच्चों please confirm. Is it clear now? Please confirm, is it clear now? So very simply, very easily we can understand these things, right? So this is a very simple thing. So based on these two properties, this is the second property, we can see the question. This question is based on just this property directly. Okay. Now, I hope this is okay to everyone. All right. Okay, now let's come to the next one. This question बच्चों you can solve without using pen. If you are having pen in your hand, just put your pen on the table, just sit like this and read the question carefully. You can get the result within the 10 to 15 seconds if you can read the question very carefully. Without using pen, we can solve this question. बच्चों without using pen, just tell me the result. Arey ma'am, it is very simple. Actually the property directly, if any two columns of a determinant P, we are having a matrix P, are interchanged, this is the important point. If any two columns of the matrix of the determinant P are interchanged, then which of the following statement regarding the value of this determinant is correct? So we can see, first of all, absolute value remain unchanged but sign will change. Both absolute value and sign will change. Absolute value will change but sign will not change. Both absolute value and sign will unchange. अरे बोल दो बच्चों. What is the answer? Ma'am, we know very well, if we are having a matrix, or if in a matrix we are interchanging any two rows or columns, then the sign of determinant will change but the numerical value remain unchanged. So my answer will be option A for Ahmedabad from here. This will be my answer. Remaining B, C, D are absolutely wrong. Only and only option A for Ahmedabad is correct here. Remaining whatever we are having here, B, C, D are absolutely wrong. Is it clear? Yes, very good. So very easily we can understand, because this is directly the property. Again I am reminding you, I told you na beta that based on the properties of determinant we are having direct GATE question. Here again you can see, right? Okay, now let's come to the next question. Again this question you can solve without using pen, literally. The question is saying perform the following operations on the matrix. Two operations are given to you. Add third row to the second row, subtract the third column from the first column. Then it is asking about the determinant. Yes, tell me. For that again you need to put your pen on the table. You need to sit like this, and I can give you guarantee, if you can understand the question, if you can read the question very carefully, you can solve the question within the 10 to 15 seconds. This is my guarantee. Now tell me what is the answer, bachcho? What is the answer? What is the answer here? Tell me, any student is having the answer? Yes, Pacho, yes, tell me. Okay, now again, just look at the question in my way. 100% you can solve it. What to do? Just read the question, put your pen on the table. You can solve this question with me, because there are two type of students in this world. The first is, they read the question, means whatever is written here, they will just check it, whatever is written, whatever the instructions are given, they will start doing. Means you, as the question is saying na, add the third row to the second row, so they will start doing third row plus second row. So they will start writing here 11, and whatever we are having, they will start writing 20, 11 and whatever it is. No. Okay, and then they will repeat the same thing, subtract the third column from the first column, and after that they will get the result, which you can get directly without approaching any single line here. What you need to learn the question, you need to read the question very carefully. I am writing this question for you again here. 3, 7, 13. Okay ji, this is 4, 9 and 2. Okay ji, this is 45, 105 and 195 we are having. Okay, now what we can see here, what we can see, just remember the properties of matrix we learned, okay, we will use later. Now right now look at here again, this first column, second column, third column. My object should be, can I get something from here? Right now to ma'am I don't have any hint what to do. Now when I am looking the numbers 3, 4, 45, 7, 9, 105, 13 to 195, nothing is clicking in my mind. But when I am looking this number again and again and again, because every number is ending with the 5. So ma'am 100% we can take something common from this third column. Whatever be the answer, but this is giving me a hint, this can strike in my mind that if my number, all the three number are ending with 545, 105, 195, so 100% something so we can take common from here, and that something can be 5. Now look at the question again, 45, 105, 195. If you will click again, you can just strike again in your mind. We can see ma'am from 45, 105, 195, I can take 15 common. Why ma'am you are saying for the 15? I can take 15 common because 15 3 ja 45. 15 7 ja 105. 15 13 ja 195. Isn't it? Yes ma'am. How you are getting? Because now I am linking with the first column and third column. If I will take 15 common from the third column, my third column will become 3. This is 3. This is 7. This is 13. Now beta, will you tell me what is the determinant of this one? Now will you tell me what is the determinant of this one? अरे अभी तो बताओगे प्यारे बच्चों. Now will you tell me the determinant of this one? अरे मैम we learned the very first property. If in a matrix any two rows or columns are identical, तो determinant को आंख बंद करके शून्य लगाना है, जीरो रखना है. If in a matrix any two rows or columns are identical, the determinant must be 0. So I will put here directly the determinant 0. How? Because I can see first and third columns are identical. Column number 1, column number 3 are identical. So this is my result. Now if we are having in this one, first and third column are identical, if the determinant I am having 0, rather you will add here the third row to the first row, or you will subtract, means you will approach any operation, the result will be same, result will not change. The result will be same, result will not change. So that's why very easily within the 10 to 15 seconds, if you can identify, you can solve the question. The determinant is 0. The determinant is 0. Bachcho, please tell me, is it clear or not? Is it clear everyone? Now let's come to the next one. This is again a very good question we can approach. It is a 4 cross 4 matrix. It is a 4 cross 4 matrix and it is asking about the determinant of the matrix given below. Look at the matrix. We are having 2 1 1 1, 1 2 1 1, 1 1 2 1, 1 1 1 2. I am giving you time to solve. I am giving you time to solve. Then I will tell you what is the approach. I will tell you what is the approach we can use here. Bachcho, just approach it, just try it, whether you can solve it or not. then I will tell you the approach, how we can solve it. Yes, bachcho, just try it. Yes, bachcho, yes, tell me the result. Let's approach it. Do you have any hint how to solve? Do you have any hint how to solve? No. Okay. Let's approach it. First of all, I can see that so many students linked this question with this method which we already learned. 1 1 1 1 1 1 plus a 1 1 1 1 1 plus b 1 1 1 1 and 1 plus c, and they will tell me, ma'am, the result is actually we are having here, so the result is actually 1 into 1 into 1 into 1. So this is the result is 1, but 1 is not in the option. 1 is not in the option. I can see someone is replying with that 2 also. Ki ma'am, as we are having this element as 2, so this is 2 into 1 into 1 into 1. So the result is A. Option means 2. No, this is not. Beta, do you understand one simple thing? Ki this one and this one is same. Are tell me whether this pattern and this pattern is same? No. Can you understand a simple or minor difference between these two manners? Beta G, look at here in this pattern, whatever is given in the question, the first number is 2. But whatever the trick or key point I delivered to you, that time I told you, na, my pattern must be same. Here I can see, means here we are having 1 plus A, 1 plus B, 1 plus C. Other than these 3, every element is 1. Other than these 3, every element is 1. Can you understand this very simple thing? Yes, ma'am. So, ma'am, this is not possible to use this method. So, I am not able to use this one right now. Okay. Then what to do? What to do? We will use this something here. We can solve this question again very easily, but with a systematic manner. So, 2 1 1 I am having. Okay. The next is 1 2 1 1. The next is 1 1 2 1. And the next is 1 1 1 2. So beta G, how I will approach it? How I will approach it? Just, yeah, very good. I can see some results. Some results. Zorkid 5 option, absolutely right. Yash, absolutely right, 5. Very good. Shabash. So 2 students I can see replying absolutely right. Very good. How it is become 5? We need to understand this point only. If I will use here the row transformation, means if I will make these 3 elements 0, then also it will not work for me. Because if I want to convert here, if I want to make here this form, so I need my very first element is 1 beta. Other than that too, we are having already same. I need very first element as 1 if I want to use this one. So I need to make this one 1. So what I will do, I will use here something else which is called the column transformation. Why ma'am you are doing with the column transformation? Because one thing strikes in my mind that here in this complete matrix we are having only two numbers, either it is 1 or it is 2. Other than that we are having no other number, right now. So we can easily approach. If I will add here at the place of column 1, I will go with the C1 plus C2 plus C3 plus C4. I want this element 1. So sorry, so I want to use here 2. I am having this one, so 2 plus 1 plus 1 plus 1, this will be 5 ma'am. Same here, 1 2 1 1, this will be 5. If I will add 1 1 2 1, this will be 5 again. When I will add here 1 1 1 2, this will be 5 again, isn't it? This will be 5 again. So I can see ma'am, by using this one, my first column earlier which was 2 1 1 1, now it is 5 5 5 5. And if in a column, if in a complete column we are having all the elements 5, we can take that 5 outside. We can take that 5 outside. So now what I can do, as I told you, my matrix will be, my new matrix will be this one. Okay, this is 1. This is 1 1 1. This 2 I can write down as 1 plus 1. Okay with that one. This is same. This 2 I can write down as 1 plus 1. This is 1 1 and 1 plus 1. Okay. Now again it is not in that form. So I will take 5 outside. So beta, when I will take 5 outside, okay. So when I will take 5 outside from this first column, my first column will become 1 1 1 and 1. Now to this form ma'am which we learned in the keynote. Now this is exactly that form which we learned in the keynote. According to that one, the determinant of this matrix is nothing but 1 into A into B into C. So this is 1 into 1 into 1 into 1. 1 multiply with, we are having 5 also outside this determinant. So this is actually 5 into 1 into 1 into 1 into 1, which is nothing but 5, my dear students. So my final answer will be option B for Bombay, which is giving me 5, not A. My final answer will be option B for Bombay, which is giving me 5, not A, which is giving me 2. Is it clear? So many students are there who used to approach, and this is 2 into 2 into 2 into 2. So they will approach here 16 also. Nah, this is not right. No, this is not right. Okay, you should know what we are approaching. You should know how we are approaching, which pattern we are approaching. That you should know. Clear? So if you know the pattern, then only you can approach it. Otherwise, you will misunderstand. Means दिमाग में रहेगा trick पढ़ाया था. What comes in your mind? Ki, yeah, we had a discussion on a trick based on this determinant. You know that a trick is there and you want to use that trick very eagerly. When you know something which is a shortcut, we want to use that thing so frequently. So you want to use that trick so eagerly, okay, by unknowingly you will approach that trick there, and that will be absolutely wrong. Okay, so you should not miss that one. You should not use the trick at the wrong place. Be careful while reading the question, because this is the only important thing which can help you, okay, which can avoid you doing the negative marking. Because if you don't understand the language of the question, still you are approaching, if you are confused with the language of question, still you are approaching, then 100% you will do the question wrong and you will get the wrong, means the negative marking. Clear? So you should be careful with this approach also. So I hope this is clear to everybody. Now let's go with this one. This is a similar pattern of approach which we used just earlier. But again still I cannot use here that trick, because in that trick I need the very first element is 1. I don't have here the very first element is 1. So still here I cannot use the same trick. Okay. So the thing which I use in the last question, the column transformation, the adding column, I will use here. Why? Because it's still here I can see if I will add these 3 things, it will be same. These 3 things, it will be same. These 3 things, it will be same. So I am going to use here again the column transformation. At the place of first column, beta ji, I will go with C1 plus C2 plus C3. So it will become 1 plus B plus B plus 1. It will be 2 plus 2B. The second will also 1 plus B plus 1. It will be again 2 plus 2B. It will be 1 plus 2B plus 1. It will be again 2 plus 2B. Now will you tell me the result of this question? Arey beta, now to I just solved the question 99%. If you tell me the result of this question now, anyone is there who can give me the result of this question? Arey ma'am, now to nothing is left. Nothing is left here. Why? Because we can see from the first column we are having 2 plus 2b, 2 plus 2b, 2 plus 2b. Arey, I can take common this 2 plus 2b. When I will take this 2 plus 2b common, so okay, let me write down here 2 plus 2b. So this will become 1, this will become 1, this will become 1. Now beta ji, can you see, ma'am, first column and third column are identical, and just go to the property of determinate. The very first property of determinate, if in a matrix any two rows or columns are identical, तो determinate आंख बंद करके शून्य लगाना है. So ma'am, the determinate will be 0. It will not take maximum more than 15 seconds. Maximum in 15 seconds you can solve this question. Maximum I am talking about. Within the 10 seconds you can solve. So between 10 to 15 seconds you can solve this question, which is a GATE problem. If you know the property, if you know the base, then only तो you can solve ना. Otherwise तो कहाँ से solve करेंगे? Very good, Yash. Is it clear? Everybody? Is it clear, everybody? Yes, very good. So this is a very simple thing you can approach. Now we are having more questions, 3-4 more questions, but okay, let's approach one more question. These two questions we will approach, and the remaining questions we will start in the tomorrow session. 2 more questions I will approach here, and then we will meet in the next session again in the live. So as you can see, this is the very first lecture of this series where we are dealing with the most important concept. So it's not only the concept. First we just discuss about everything related to that concept, and then now we are approaching the GATE question, including the good examples also. So this is a very superb combination of concept, means the most expected concept plus very good questions. So you should not miss this one. If you are watching this in the live, then you should again join live in the next session. If you are watching in the recording, then also you should join live in the next session. And you should share the link of this video with each and every student who is preparing with you for the GATE exam, so that everyone can join with us, because this is simply very free, means no cost is there na. So if you will share, then more students like you can join with us. Clear? So now let's approach this question we are having. Which one of the following does not equal? It is asking about does not equal. If we know the basic thing, one very important key rule you should understand here, कि if I am writing one very basic or important key rule you should know बच्चों here, कि if I am saying, okay, if I am approaching in a determinate any row or column transformation, so it does not make any difference to the value of determinate. So determinate will not change by transformation of rows or column. Okay, so that's why to we said na ki determinant of A is equals to determinant of A transpose. Even if I will use any row or column transformation in any matrix, then also the determinant will be same. So determinant will not change by row or column transformation. Clear? So here I can see it is asking about does not equal. My matrix is 1x x square, 1y y square, 1z z square. Let's start from the option D. If I will check here, I can see what is in the option D. I am having 2x plus y x square plus y square. So by just reading first row of this matrix, I can understand this is written as 1 plus 1. Adding row 1 and row 2. x plus y, x square plus y square. Yes, this is possible. Same here, 1 plus 1, 2, y plus z, y square plus z square. Yes, this is possible. And third row you are taking as it is. Okay. So this is absolutely right. I need to find out which is not equal. This is equal. This is equal. I need to find out which is not equal. Then I will go to the option C. In option C, I can say this is x minus y, means actually you are doing here at the place of R1, you are doing R1 minus R2, which we can do simple row transformation. So 0 x minus y, x square minus y square, correct. 0 y minus z, y square minus z square, correct. So this is also right. I need to find out not right, not correct, not equal. Option C and D are right. When we talk about option B, we are having first column as it is 1 1 1. Okay. Now they are adding in this case columns. So you can see this is column 1 plus column 2, x plus 1, y plus 1, z plus 1. This is column 3 plus column 1, x square plus 1, y square plus 1, z square plus 1. Yes, this is also possible, ma'am. This is also right. Option B, C, D are absolutely right. I need to find out which is not equal. So not equal, now we are having only option A which is not equal, which is the remaining one. Okay, so this must be the answer. But why this is the answer? You should know the reason. You should know the reason why this is the answer. So here I can see 1 1 1 is this same. Okay, 1 1 1 is same, ma'am. Now what is here? We are having x into x plus 1, means this is actually x square plus x. This is y square plus y. When I will open, this is z square plus z. So what you did, you are just adding here column 2 and column 3, x square plus x, y square plus y, z square plus z. Okay, this is okay. You are adding here column 2 plus column 3 and you are putting at the place of column 2. Okay. But when I am checking here the third column, it is x plus 1, y plus 1, z plus 1. Which is absolutely wrong. Why? Because when you are saying x plus 1, y plus 1, z plus 1, you are adding here c1 plus c2 at the place of column 1 you are doing, or at the place of column 2 you are doing. These are the column 1 and column 2 only, na? So either you can use here at the place of column 1 c1 plus c2, or at the place of c2 c1 plus c2, but it should not be in the third column, na? It must be either in the first column or in the second column. It must be either in the first column or in the second column, beta, but you did it wrong. So that's why this is the only option which is not equal. If you want to make this one also equal, then if you are interchanging here after the transformation, then you should put here the negative sign. Because we learned if we are interchanging any two rows or column in a matrix, the sign of determinant will change, value remain unchanged. So if you will put here negative sign, then this is also right. But right now we are not having negative sign. So that's why this is absolutely wrong. So this is the answer. This is the answer. Okay. So this is the answer. Very easily we can approach it. Very simply we can write down the result. Clear, guys? And the last question is a basic example. Determinant of matrix A is equals to the determinant of its inverse. No. We know the determinant of matrix A is equals to determinant of A transpose. Changes by performing row or column operation. No. If we are interchanging any row or column, or we are approaching any row or column transformation, determinant will not change. Next is determinant of A plus B is less than to determinant of A plus determinant of B. No, we don't have any enough proof for that one. So this is also not true. So is equals to the determinant of its transpose. Yes, this is true. This is absolutely true. Other than this, all are false. So this is my answer. Other than this, all are false. So this is my answer. Okay, bachcho. So I am giving you this question as a homework. You can try this question, as tomorrow I am going to deal with the inverse. But before starting the inverse, we will talk about few more questions of determinate, 2-3 more questions of determinate, and then we will talk about the inverse of matrix. Okay, and then we will talk about the inverse of matrix, which is again important. For that also we will learn the trick of inverse of matrix, how to find out in the easier manner of inverse of any 3x3 matrix. Clear, bachcho? I hope you enjoyed the session with me, pyare bachcho. If yes, then you should like the session, you should share this one, so that more students join with us in the next live session. Tomorrow we will have the same timing session, means the 7 to 8:30 will be the timing of this session. Okay guys, so see you again with the next session. You can try this question as a homework. Stay connected to IMS GATE Academy YouTube channel for more admission inquiries. If you want to join IMS GATE Academy, the details are mentioned in the description box. You can join our team. You can join the best coaching for your GATE examination. Okay guys, chalo, bye bye, take care all of you. Good night. Thank you.